Hello, everyone. Welcome back to the webinar of GenAI. So, we're discussing a lot of prompting techniques, and today we'll be discussing about chain of thought prompting. So, here's a comprehensive explanation of chain of thought prompting. Let's go about the concept, and then we will also include code explanation. So, what exactly is chain of thought prompting? Chain of thought prompting is a prompting technique for large language models, LLMs, where the model is encouraged to think step by step before answering a question directly. So instead of generating an answer directly, it will first generate the intermediate reasoning steps and then give you the output or the answer. So why exactly do we need to use this chain of thought prompting needed? Why exactly do we need this chain of thought prompting technique and when do we use it, right? So while these LLMs, large language models, are very good at language tasks, they often struggle with multi-step reasoning tasks. For example, solving mathematical world problems, logical reasoning problems, or even common sense inference. This is because default responses tend to jump to some conclusions. So, chain of thought will help guide the model to think like a human, breaking down the problem into some manageable parts. How exactly does chain of thought prompting work? Instead of giving a direct question answer format like this, for example, we say, let's say a question that if you have two apples and you buy three more, how many apples do you have? The answer being five apples, right? So we use chain of thought prompting technique to explicitly walk through the steps. So if we give the same question, let's say if you have two apples and you buy three more, how many apples do you have? Answer can be, let's think step by step. First of all, you have two apples, you buy three more. So the total apples is equal to 2 plus 3, which is equal to 5, and then we arrive at the answer 5. This will help the model simulate reasoning paths which will lead to higher accuracy, better generalization, and even help with the reduction of hallucination. Right? There are different types of chain of thought prompting again. So there is zero shot chain of thought, which will add phrases. When you add a phrase like let's think step by step to the prompt, the model attempts to reason without even any example. For example, I ask a question, what is 25% of 80? And the answer saying let's think step by step. There's also few shot chain of thought prompting where we provide a few examples of step by step reasoning before the main question, and this is the more effective. This is more effective basically, um, especially when you're using it for small or base models. Then we also have automatic chain of thought, which is chain of thought which is generated automatically using techniques like self-consistency or self-refinement. So let's look at an example. Let's look at a real COT prompt for a math problem. For example, we ask a question, a farmer has 4 baskets. Each basket contains 6 apples and 3 bananas. How many fruits are there in total? And we give a prompt saying, let's break down the question. So it will start answering that each basket has 6 apples and 3 bananas. So that means each basket has 9 fruits in total. And 4 baskets in total, which contain 9 fruits each. So it will multiply 4 into 9 and give you the answer as 36 fruits. So the reasoning mimics how a human would solve any problem. Key benefits of using this chain of thought prompting would be improved reasoning. Okay, it forces the model to consider the intermediate steps and debuggable output. So it's easier to verify or correct your step by step logic, and obviously better performance, especially on multi hop questions or complex arithmetic. And then it aligns with the human cognition. This will mimic how humans naturally solve problems. What are the limitations of chain of thought, right? It doesn't work well with small models. Models with, for example, the small language models which are trained on less than 1 billion parameters, this chain of thought prompting will not work well. And chain of thought prompting can be verbose. It is not always suited for a short answer task. And the quality of steps, intermediate steps, will still depend on the model's pre-training. And what are the applications of chain of thought then? We can use it for mathematical problem solving. For example, when you're writing exams like GRE, SAT, right? When you're solving logical puzzles, when you're doing common sense reasoning, when you want to get into medical and scientific explanations, maybe you also want to break down a legal case, okay, or any financial risk assessment. These applications, for these sort of applications, chain of thought prompting can be used. There are certain recent advances with chain of thought. There is self consistency decoding, which instead of picking the first answer, it will generate multiple chain of thought answers and pick the most common final result. Then we also have tree of thoughts, which will branch and evaluate. It's basically branching and evaluating multiple chain of thought paths. We will look at tree of thought prompting in the future upcoming webinars. There's also program-aided chain of thought, which uses Python code to verify or enhance the chain of thought answers. So to conclude, chain of thought prompting is like giving the model a whiteboard to show its work. Instead of guessing the answer directly, it will explain the path, it will improve the transparency, and it will allow you to enhance accuracy in decision making and complex tasks. So this is about chain of thought prompting. Now let's go to the script, coding script. Okay, the first thing that we're doing here is installing Transformers Accelerator, Accelerate and Torch. After installing the required libraries, we will get into importing, right? So from Transformers library, we're importing an auto tokenizer, auto model for casual LM, and pipeline as well. And the model that we are, so you import these utilities from the Hugging Face Transformers library. This auto tokenizer and auto model for casual LM are auto classes that will load the correct tokenizer or model based on the name of the model. Then pipeline is a high level API for tasks like text generation, okay, which is not used in the snippet directly but can simplify the inference. So the first thing that we're doing here is loading the model and tokenizer. You can see here auto tokenizer from pre-trained model. This will basically load the tokenizer, which will convert the text to model understandable tokens. Then auto model for casual LM. Yes, this will load the casual language model, which is used for next token prediction, which is suitable for text generation again. And we say device map parameter as auto. This will automatically place the model layers across available GPUs and CPU or CPU, whichever is available. Then you have torch D type as auto. This will use appropriate precision like float 16 or B float 16 based on your hardware in order to improve the speed and memory usage. And the model itself that we're taking here is Mistral 7B instruct B0.2. So Mistral 7B is a 7 billion parameter open weight language model, which was released by Mistral AI. It's based on the transformer architecture with improvements like grouped query attention, GQA, and sliding window attention, making it very efficient and powerful. This instruction tuned means that it was fine tuned on data sets where it learned to follow natural language instructions. This will help it behave like ChatGPT. Right? Okay. Then we're defining the chain of thought example itself, where we say we were giving a prompt that answer the following mathematical problem by reasoning step by step. And we've given a question here which says if you have three cars and each car has 4 wheels. Each wheel has 5 bolts. How many bolts are there in total? And we give an answer on how it can break down and arrive at the answer output. We say let's break it down. Each car has 4 wheels, so 3 cars have 3 into 4, total 12 wheels. Each wheel has 5 bolts, and we have 12 wheels. So 12 wheels into 5 bolts gives us total 60 bolts, and the final answer is 60, right? So this is a chain of thought prompt where the model is guided to think step by step before giving a final answer. Such prompts will help in improve reasoning. It will make the model more interpretable and are especially useful for mathematical calculations, logic, and scientific question and answer tasks, Q&A tasks. Finally, we will tokenize the prompt and run it. Okay. This tokenizer will convert the prompt into token IDs and attention masks. Then we have a parameter here, return underscore tensors as PT. This will return the PyTorch tensors. And it will, this to model dot device will ensure the input goes to the same device, CPU or GPU, as the model. And finally, we generate the output response. Model.generate is used to predict the next tokens. Maximum tokens we've specified as 200. This will limit the output length. And we say do sample false. This will ensure deterministic output or greedy decoding and avoid randomness. And when we say response is equal to tokenizer.decode, this will convert the generated token IDs back into the human readable text. And when we say skip the special tokens, true, it will remove special padding tokens like pad, s, etc. And finally, when we say print the model response, this will show the final reasoning and answer from the model. So what are the key components that we're using? Auto tokenizer, which will convert text into tokens. Auto model for casual LM, which will generate tokens based on the input. Then we have Mistral 7B instruct v0.2, which is the open source instruction following the LLM. And prompt, the chain of thought prompt task to simulate the reasoning. Generate will core generate the function, and decode will convert the tokens into human readable response. So this is the coding of a chain of thought prompting, and that's about chain of thought prompting. Coming ahead, we will also discover a few more prompting techniques, advanced prompting techniques like tree of thought. So please stay tuned. I would also like to request your attention, wherein 360DigiTMG is trying really hard to upskill all the IT professionals into this field of data science and data analytics, which is becoming highly competitive. And you can see there are a few success stories from our side. So all the students who have successfully done the course with us and gotten placed, right, in huge top-notch companies. You have the big four firms like EY, Deloitte, okay, someone who got placed in Flipkart, all different types of MNCs. You can go ahead with this. You can go through this and see for yourself how people are able to upskill themselves. And we are also doing a lot of industry connect expert talks where we bring in employees working with MNCs, working as data scientists, okay, working for AI projects, who are leading these AI projects. And we are able to get some tips from them that what are those essential industry relevant skills that you should have in order to um, establish your career in the AI field, right? So please go through it, and you can head over to YouTube. You can click on you can type in 360digitmg.com, and you can find our YouTube channel and click a follow, subscribe, and you can share these videos. You can go through the videos, and obviously you can contact us at any point of time, right? So do follow us on LinkedIn, YouTube, all channels possible, where you can get the information, you can get upskilled, because we do release a lot of free courses as well on YouTube. Python end-to-end free courses, SQL, Tableau, Power BI, Advanced Excel, etc. All the machine learning algorithms, even domain analytics, we do a lot of projects. And we release these videos on YouTube for free. So you can subscribe, you can go through these videos. Thank you so much for joining in today. Thank you. I'll see you next week with another exciting prompting techniques webinar. Thank you.